Hi everyone, welcome to today's session of Energy Performance Assessment in Furnaces. Okay, so we'll be basically dealing with what a furnace is. Furnace, as you know from the name, it could sometimes strike you that furnace is something, a machine or an equipment that is used for heating. It is basically heat energy absorbed. It takes in the material, heats it and give it to the output. So what happens, this is a word which is very commonly, at domestic applications, we do not come across furnaces much, but it is basically used in many manufacturing plants, in bakeries, in companies and industries, etc. So this is one of the main equipment of industries. Industrial equipment, the most important industrial equipment is furnace. So what happens when a large industry has to operate, we have to make it sure that each of the equipments are in proper condition. They have been assessed properly for its efficiency, its energy consumption, etc. If they are not working properly, it will affect the overall output of the manufacturing plant. So periodic assessment is very necessary for such equipments like furnace, boilers, etc. So in this session, in today's class, what I am willing to take, or what I would like to explain is the different parameters which will affect the furnace performance, how we can deal, how we measure it, what are the criteria that are used. Okay, so just let's go through the syllabus. We need to know what an industrial heating furnace is. So as I said, furnace is any device that is used for heating the materials. No, so in detail we'll just see the different types, etc. And after that we'll move on to the purpose of this test. Why should we do such a test? As I said, in short, these furnaces are always throughout, they're functioning 24/7, 365 days in any industry or a manufacturing plant. So they have to be periodically assessed and their performance has to be always maintained properly. Only then it will give up to the standards. So such performance assessment is very important. So what are the tests and what are the standards, standardization techniques we used, as well as what are the parameters to be measured and the methods that will be dealing with, we will be dealing with that much in this session. Okay. So let's come to the first topic. It is the industrial heating furnace. So as I said, a furnace is any device that is used for heating materials. It is a user of energy. You can give steel, aluminium, etc. That can be taken in the solid steel, can be converted into molten steel. That could be needed for many fabrication applications. So that will depend, or that will be dependent on the company or the manufacturing plant that is used. Any equipment or many manufacturers require things in the heated or the molten form, or maybe even in the gaseous form. Such things can only be generated by heating it in a very large equipment called furnace. Okay, so the basic definitions: it is any device that is used for heating materials. So broadly, they are classified into two types. One is the batch type, and other is continuous type. So from the name itself, batch is a type of furnace which treats a particular box or a particular quantity of material at a time, and then it goes on to the other function. That's all. It just heats it, and this material is taken outside for the other functions, or maybe for doing various other occupations or various performances on the next batch. So batch means we are only considering a particular slot, and after that furnace doesn't work. Whereas the continuous type means the furnace is part of an assembly line. Assembly line means continuous, the next batch comes. In cycles, the next batch comes, it works on that, and it just keeps on going. So there are different types of continuous type furnaces. One is the pusher type, and the next one is walking pin type. Other is rotary hearth type and walking hearth type. So these are the mostly continuous type furnaces are used in almost all the industries, because there the functions happen 24/7 all the days. So this is a continuous process. So more assessment is needed for continuous type furnace. Okay, those are the two types. Batch type means they just treat one load at a time. Then as I said, it is a user of energy. Heat energy is being utilized here. So to generate the heat, that heat is main source of heat is from fuels. We all know that fuels generate the heat. So furnace oils, there are different types of furnace oils that are used to that are burned in order to produce the heat. Few examples of such furnace oils are one is the LSHS, which is low sulfur heavy stock. Then we have light diesel oil, LDO, and also even electricity could be used. Electricity could be used for generating heat inside a furnace. Okay, these are the basic, most commonly used forms of furnace oil. One is low sulfur heavy stock. Then we have light diesel oil, and then there is also electricity that is being shown here. This is a LSHS, this is LDO, and this is finally a furnace chamber which works based on electrification. Okay, so these are the different fuel oils which can generate the heat inside a furnace. Okay, then why should we perform the test? As I said, the performance has always to be assessed because we need to know what is the efficiency, what is the energy consumption, what is the heat balance. Heat balance means heat input should compensate, or the amount of heat you give into the furnace should be sufficient to heat the material. The material is also called the stock. It could be steel, aluminum, or any metal. Anything that is to be heated, we in the furnace terms we say a stock, or it can also be called billet. Billet or stock is the general term used for the material inside a furnace. Okay, so we should perform the test so that we need to know the efficiency of the furnace, we need to know the energy consumption of the furnace, as well as we need to know the heat balance. Heat balance means whether there is a proper proportion according to the heat given, is it being heated up. So these things only if we confirm that and verify that it is working up to the standard, it can be used in any industry or manufacturing plant. So in general, performance test is the key. It is a very important role for assessing the current level of performance and finding the scope and improvements and the productivity. You need to know whether there have to be any improvements, whether it is productive enough, whether the device is productive enough, and that is the basic purpose of performing a performance test. Okay. So there are certain terms. As I said, we need to measure the heat balance, efficiency, as well as the energy consumption. So these are the equations for measuring those terms. First one, let's take furnace efficiency. We know that any efficiency is always output of the system divided by input, right? So here in this furnace heating case, what is your output? Your output is definitely the heat coming out of the material. The amount of heat that is contained in the material is the heat output. That is the heat in the stock. As I said, in furnace, always furnace terminologies, the material that is being heated is called the stock or billet. It is always measured in, the heat is measured in, kilocalories. That is KCAL, means kilocalories. So heat output is the amount of heat in the stock. And what is your input? Here we are giving fuel. These fuels will generate the heat, right? So what is the heat input? Heat input is the heat in the fuel or the electricity. As I said, fuels can be of different types. One could be from coal, you can generate electricity, or it could be LSHS, low sulfur heavy stock, or light diesel oil. So you need to know the amount of heat in the fuel. That is your input. The heat from the fuel is transferred to the object or the material called the stock. That is your output. So basically, efficiency is heat output by heat input, where heat output is the heat in the stock, heat input is the heat in the fuel or electricity. Both are measured in kilocalories. So by taking the ratio of this, we get the furnace efficiency. That is one important parameter. Okay. Next parameter, as I said, is specific energy consumption. That is just to get the heat balance. You give some heat to the material, or you give the fuel produces the heat, and this heat should effectively get transferred to the material, right? So how much of energy is being consumed? That we can measure by taking the amount of energy consumed by quantity of material processed. How much of energy is being consumed in the process? You divide it by the amount of material, the quantity that is being processed. So let's see what are the units for that. As we can see, quantity means always it is measured in kilograms or tons. So in a manufacturing plant, we always have abundant materials. So it is all basic unit is tons per hour. How much tons? 1 ton, as you know, is 1000 kilogram. So 1 ton, or how much tons are being processed, how many tons are being processed per hour will give you the quantity of material processed, and the amount of energy consumed, that needs to be measured. Okay, so the ratio of those two will give you the specific energy consumption. So far we have seen what a furnace is, the basic purpose of a furnace. There are two types, as I said. One is the batch type and the other is the continuous type. Then we have the why should we perform this test? As I said, these furnaces have a very important role in the industries. So they need to be properly validated and verified timely in order to ensure its proper performance. So to ensure the performance, we calculate these two parameters. One is the furnace efficiency, output by input. Another one is the energy consumption. That is amount of energy consumed by how much of material is being processed. So we cannot just randomly do all these tests. There have been organizations which have already set up the protocol, or they have set up a set of procedures that has to be followed. So for furnace testing, for testing of continuous furnaces, we follow the reference standards formulated by Japanese industrial standard, that is called JIS. They have formulated a set of procedures. We have to follow those procedures in order to validate the performance of a furnace. Okay, so this method is used for purpose of establishing. We need to find out the type of losses that happen inside the furnace. This is basically used in practical industries, practical calculations in industries. Okay, So heat balance method, how we are going, let's see a figure of how a furnace functions. As I said, this is a chamber, this is the heating chamber. In this heating chamber, we give the fuel. The fuel is our input, which could be electricity, it could even be light diesel oil or LSHS. That is your fuel. That fuel gets heated, that fuel on combustion will generate the heat. That heat will heat up the stock or the material that has to be heated, and from the outlet we take out this load, that is our material. Okay, so here what happens is, when you give this, the whole of the energy doesn't get effectively utilized. A lot of losses occur here. As we can see, there is an opening here through which we take the load. So through here, when we take, there are certain openings through which heat can, that is called the opening loss, that amounts to about 1 to 2%. The losses get some amount of heat gets lost through those openings. And also these furnaces over the time will have some wear and tear, right? So what happens is, their surfaces will develop small cracks. So through these cracks also, what can happen, losses can occur. That is called the wall losses. Through the walls, loss can occur. Through the openings, loss can occur. Then there could be, see, the insulations are there. If it is not proper, losses can occur. And the heat, so those have been specified in percentages and shown here. Okay, so opening loss accounts for about 1 to 2%. We have wall losses about 3 to 10%. Then there is stored heat, the amount of heat that doesn't just go out to the material. Effectively, it doesn't go out, it stays inside the furnace itself. That amounts to almost 2 to 5%. And majority, these are just the minute losses. We have the main important loss called the flue loss. So what does the term flue means? Flue means the waste smoke. When you heat a material, a lot of smoke gets generated. We have seen that when we travel through roads, we have seen from big manufacturing plants and all, we have seen smoke coming out. The waste smoke is called the flue smoke or the flue. The flue gas will account to almost 20 to 50% of the loss. That is, when this burning combustion happens, a lot of smoke is being generated into the atmosphere. So that was supposed to be effectively transferred to the load, but that didn't happen. Due to the quality of fuel or something, a lot of smoke gets generated. That is called the flow losses. That accounts to 20 to 50%. So what we can do is, to avoid maximum loss from this flue gas, from the heat from the flue gas can again be regenerated. Okay, that is called the recycling. You are again recycling the flue gas, and that heat is again being given into the fuel for generating heat. So I hope the basic function of a furnace is clear to you. We have a chamber for heating the material. Then the losses that happen through the opening, losses can occur. Through the walls, losses can occur. There could be some amount of heat that is being already stored inside a furnace. Also, flue loss accounts to the major component of a furnace. Flue loss is the waste smoke. So a lot amount, almost 50% of the heat gets lost through the flue loss. So what we do is, through the flue gases, we again try to recycle the heat, and that is again being given into the furnace for heating. So these losses which I just told have been just jotted down here. Similar to, so how do we calculate the efficiency? The efficiency calculation, as we said, there is an equation like output by input. That is the direct method of calculating. We also have one more method which is called the indirect method. Okay, this indirect method is basically what we do is, we calculate the heat input. We also calculate the losses. So the heat input minus losses will give you the output. That is another way of testing the efficiency. So this here it is calculated similar to the indirect method. Indirect method we have already discussed that in the boiler section. So in that same method, what we do is, the total heat input is calculated. From that we subtract all the losses, and then we get the output. Okay, it is calculated after subtracting all the losses that occur inside. Different losses are mentioned. As I said, one happening through the through the openings, through the walls, through the skin, etc. That is being subtracted from the input to the furnace. So that will give you the value of efficiency. So suppose the material we are heating requires a change of state. Suppose the steel you give, we are taking out it in the molten state. Okay, we are heating it to such a temperature that we need a semi-molten or a semi-liquid state of steel. So in such cases, a latent heat of vaporization is also there. That also has to be considered in addition to the total energy requirement. Okay, that is mentioned here. If the process requires a change in state, then what we have to do, the sensible heat, that is an additional quantity, that has to be considered. It is called the latent heat of fusion or vaporization. That has to be added to the total energy requirement. So what are the parameters to be measured? As I said, we are measuring the total input, and there are losses. So just see the parameters. One is, you need to know the weight of the stock. Only then you can know that, as I said, tons per hour is the quantity of material that is processed. That to know that, you need to measure the stock, or it is also called billets. Then you need to know the temperature, at what temperature it is being fed. Also, the temperature of the furnace walls, the area of the furnace, the flue gases, the waste smoke that comes out of the furnace has to be measured. The temperature has to be measured. The components, you have to analyze the different components. There could be oxides of sulfur, oxides of nitrogen, etc. So you need to closely monitor what are the type of components coming out, whether it is causing environmental degradation. Such things have to be monitored. Also, the fuel oil consumption, how much of fuel oil is being consumed for heating up a particular, maybe 1 ton of steel is there. How much of fuel is required? That also has to be monitored. So for that, we need different types of instruments. Okay, so we need infrared thermometer. We know infrared thermometer is a non-contact type. We are not keeping it directly, but to know the inner temperature of a furnace, you cannot directly go keep a thermometer there. For that, you use an infrared thermometer. Then we have a surface thermocouple, that is basically to know the surface temperature. For that, you can keep a direct contact type thermometer. Also, we have a fuel consumption monitor. As I said, we need to know how much of fuel is being consumed. For that, a monitor has to be kept. Then also there are different reference manuals. You need to know the amount of the correct constant values like specific heat capacity. Then there are a lot of Stefan Boltzmann constant. Such values have to be always taken from the very referenced manual textbooks or books. Okay, so these are the instruments and the parameters to be measured. So just the efficiency is once more given. The efficiency is heat output to heat input. And how do you measure the heat? We know the basic equation of heat is Q is M into C into delta T. That is it from the law of thermodynamics. We know that the quantity of heat transferred to any material is a product of mass into specific heat capacity into its change in temperature. So let's just see all those terms in detail. Q is the amount of heat that has to be or the imparted to the material. How much of heat to impart to the stock is Q. To find out, you need to know the weight of the material. It could be in kilograms or tons. Then you need to know the specific heat capacity. That is, specific heat capacity is every object has a particular specific heat capacity. It is the amount of heat required to raise 1 kilogram of substance through 1 degree Celsius. Temperature required to heat up a 1 kg substance through 1 degree Celsius is called the specific heat capacity. That is constant for any particular material. It just varies from material to material. Okay, then we have two temperatures, T1 and T2. T1 is the starting. At the beginning process, what is the weight of the temperature of the stock? That is T1. And at the end, after you heat up, what you get is T2. Okay, so with these equations, you can find out the heat that is being imparted to the stock. Then what are the different factors that will generally affect the performance? As I said, there could be many factors that affect the performance. One such is improper design. If it is not properly designed, it could affect your overall efficiency. Then we have absence of waste heat recovery. As I said, the flue loss, the flue smoke is again being used. If you do not efficiently use it, the performance gets affected. We have improper operation. It has to be annually or quarterly maintained. Proper maintenance has to be done. Inefficient burners, if the fuel is not of proper quality, burners are of not proper quality, such things will also affect the proper performance. Okay, so these are the basic. You need to know certain terms and terminologies which are most commonly used. One is the radiation heat transfer. As I said, furnace is heating a lot of getting heated up, no, so a lot of energy gets radiated to the atmosphere. So that is quantified using radiation heat transfer. Then we have a furnace utilization factor. Utilization factor is nothing but the quantity it can process at a time. The amount of load it is able to utilize at a time is the furnace utilization factor. Then we have standby losses. These are the losses which have already been discussed. There are different types of losses that occur through the openings, through the cracks that get sedimented, etc. Okay. Then there is a draft control. Draft control is nothing. We have to take out the smoke, flue gases which comes have to be taken out of the furnace, right? So that is being pressurized out or taken out with the help of exhaust or pumps. So that has to be properly controlled. The required quantity of flue gas have to be taken out properly. So that is also another important parameter. Then we have scaling problem. Scaling is nothing but the deposition of these material itself gets deposited on the bottom sides or the walls of the furnace. This will eventually affect its performance. Even if it is steel or aluminum or copper, they will, in the heating process, a part of it will get deposited on the walls and will cause a permanent scaling. Through that, the efficiency will reduce a lot. So these are the different parameters which will affect the performance of a furnace. So in general, let's just do a quick summarization of what we learned. We saw what a furnace is, what are the different types of furnace, then why do we do such a test? Such a test has to be done because it has to be always monitored and verified. How do we test? Using the equation of specific energy consumption and the efficiency. So in that efficiency and energy consumption, a lot of terms come like heat in output by heat in input. How do you measure that? You have an equation Q equal to MC delta T. So what are all those terms? You should understand. Okay, then what are the different types of losses that occur? So I said there are losses like flow losses, losses on this due to scaling, due to openings, due to cracks. So different types of losses are also there in a furnace. So with this, we come to the end of the session. Hope it is clear to you all. Thank you.